Welcome to our session, Eliminate Java Deserialization Attacks. In the first part with Steve Poole, it's all about Java serialization vulnerabilities and why Java serialization is a horrible security risk. In the second part of this session, I like to introduce you to the MicroStream open source project, which is a high secure serialization you can use as an alternative to the Java serialization. Steve is a very experienced Java developer. He's a developer advocate at Sonatype, a security champion, a DevOps specialist. He's working on Java SDKs and JVMs since Java was less than version 1. He works on various JSRs. He's a committer on open source projects, including ones at Apache, Eclipse, and OpenJDK. He's also a member of the Adopt OpenJ group and well known as a speaker on international conferences.
Hello, I'm going to take you through Java serialization, a quick tour through why we need it, so basically what it's for. We'll talk a little bit how it works and how it gets exploited, and then I'll wrap up a little bit with some of the things that you could do to reduce some of the exposure you could get from using Java serialization without considering some of the consequences. So why do we need serialization in the first place? Well, you're a Java developer, you have an application, you've created an application with many Java objects, and those Java objects relate to each other. So you always have graphs, large graphs of Java objects. And that's what we use Java for, that's its strength. And as such, we build quite sophisticated applications with these complicated data structures. And that's perfectly reasonable, except for situations where you realize that you'd like to persist that configuration because you'd like to be able to perhaps stop the application and restart it at some point. Maybe you've got a configuration setup that you saved and you would like to be able to persist it. But more likely, you're also looking for a situation where you need to share data with another JVM. So for whatever reason, and obviously there are many reasons why you want to do that, your challenge is to take a Java object graph from one system outside the JVM to another system. And obviously you'd like the structure at the other end, the classes, the objects, the relationships, to be identical to what you have on the initial system. So Java serialization is there to help you with this sort of idea of persisting graphs of objects, for bringing it back to a JVM later, and for sharing graphs of objects between systems. Now, we share graphs of objects between systems all the time, from whether it's using the persistence APIs, but with your RMI, remote EJBs, there's all sorts of places where serialized versions of Java objects, the graphs, are shared between systems. Sometimes it's built in by using some API that you may not be aware of. Others, it may come from being a little bit more explicit. So for instance, sometimes people will take a series of Java objects, can turn them into serialized form and put them in a cookie, because then they can retrieve them later. And if it's a complex construction that you're dealing with, it may be the right answer. But however you use it, it's pretty clear that Java serialization is used all over the Java world. Anyway, you can find this class, object input stream, you can guess that somebody, something, is doing Java serialization. This is the sort of front door, and its opposite object output stream, which are the classes which do the conversion from a Java object into the output stream, the binary format that you can use to share. So here's a query from GitHub from a little bit of time ago, and you can see just how many there are then. But as I said, Java serialization is very, very important to us. It's very useful, and therefore it's in use everywhere. Using it is easy. Take your Java object, get it to implement Java serializable. That's it, and suddenly you can now be part of the party. Using it is easy. So I said object output stream. Well, here's a couple of examples from pseudocode. First set, create an output stream where you want to put the bytes, wrap it in an object output stream, write your object. Going to get it back, create an input stream, wrap that with an object input stream, read the object, and cast it to whatever you expect it to be. There, simple. And of course, it's not just the object that you're saving, it's the object and any of its objective relationships, whatever fields it's got, whatever objects they've got, lists, maps, you name it. It's all going to get easily written down to disk and brought back. And if you don't opt in, if you don't implement serializable on your object, then there'll be an exception, which is sort of what you'd expect and what you'd want to have happen. So it's a very useful tech, hence the fact that it's being used everywhere. It's very easy to use, which makes it even more popular. And most of the time it's fine, except, well, there are some side effects, potential side effects. And nowadays those side effects are mostly there being exploited by the bad actors. And there are many bad actors there who are doing what they can to attack your systems through your unwatchful use of Java serialization. So let's talk this through in a bit more detail so you can see how this works. Let's take the first box here is some pseudocode. I have a class called OC1, implements serializable, and it has a field called field of type string called hello, which has the word hello. So second box, I instantiate that class and then I write it to a string. You can imagine all the code around this. And I get some bytes. Somewhere I get some bytes. Now, this bytes that get written has structure. There's all sorts of interesting fields in there. And and as you'd expect, it's quite a sophisticated structure. So I'm not going to talk about it this way. I think this is just too complicated. So let's reimagine the way that serialization is stored on the disk to something a little bit more human readable. So let's think of it like this: a series of fields with values and obviously nested values as things go through. Lots of these fields are just there to get you going, but there's some things that are worth calling out right at the beginning. There's one at the top called serial version ID. That's a field to make sure that the class structure that you're using that you're instantiating, its structure matches the same structure as the class that was used to write this string. Which obviously, if you had different structures, different fields, for instance, then you can imagine bad things would happen. So this is a check to make sure that the object structure that you use to create the byte stream is the same structure as that's being used to load it up again. Having said that, actually, it's not really quite like that, because actually the data stream that gets written and read doesn't really rely that much on the structure of the class. The relationship comes from the names of fields. And you can see that UTF-8 field name piece in the middle there, which is hello. What this serialized form actually says to the Java deserialization process is, go to this class and create an instance of it, and then create this string, and you can see it says string and the string value of hello. Create this string and insert it into the field name that's called hello, and repeat. So serialization allows you to take those complex graphs, turn it to bytes, transfer them, bring them back. This is what it's all about. That's really good. That's really wonderful. But I just said something that maybe you're beginning to think that it's not quite that simple. So I said about self-defining. So here we are again. We have a string called hello, and we have a field name called hello, which is where we want to put the data. So what happens if the bad guys take this data and replace the string with a number? It's just bytes. So what happens if I change it to say insert the number 1 into the field called hello? What happens? Well, luckily you get an exception because you get a class cast exception, as you would expect, which is pretty good. So then you may say, well, are we safe? So what's all the fuss about? If all of the controls are there, why do we talk about serialization being such a bad thing? Well, serialization is a bad thing because of the way it's exploited, and as you'll see, based on self-defining data, and to be honest, the way that Java developers sometimes write the classes, you can see why this can be exploitable. So look, let's take this class that we created with this hello field, and let's convert it into one that looks a little different. Let's rather than a string hello, let's have an object hello. I can still assign hello to it because that's a string, and strings fit in a class called and a field of class type object. You know that's the way it works. So let's take that new object called a new class called OC1 with field hello of type object. Well, look, now I could put in an array and I wouldn't get a class cast exception. I could change the byte stream to put a hash map in and I wouldn't get an exception. In fact, I can put anything into that byte array, into that serialization byte stream, and have it end up in the object slot called hello. Now, you may not think that's a bad thing. You may think that's silly, but it may not have bad effects. Well, it does have bad effects, and we'll talk about that in a sec. So, self-defining data streams give control to the data stream. The structure of the data should ideally be defined by the classes that you're reading into. But Java serialization doesn't do that. Java serialization works on whatever the data stream is, the structure is. And the deserialization process will construct objects and put them into those spaces if they make sense. And if they don't make sense, you'll get an exception. Right? But it's even more sophisticated than that, or more challenging than that. Let's imagine we have this class called foo, and it has a static initializer, and it has a instance called a constructor called foo, of course, and for some particular reason, we're just going to print out what happens when. So imagine it's the very, very first time this class has not been loaded, and we're going to instantiate it. What do we get? We get two different outputs, which I realize probably my face is over them, but there we go. One says static initializer, and the other one says object constructor called, which is what you'd expect. The static initializer message comes because the class is loaded for the first time, and the object constructor is called because of instantiated foo. And I will get that obviously every time that I construct an object. I'm going to expect, every time I instantiate an object, I'm going to expect to see that message. Okay. So let's go back. Now I have this object, this class called OC1, with a field called hello of type string. Self-defining data, remember. So I'm going to self-define that I want the field hello to create and to hold an instance of this foo class. So what happens? What messages do we get out? Do I get the static initializer message from foo? Do I get the constructor message from foo? Do I get both? Do I get neither? Well, what do you get? We get the static initializer called. Remember, this is in the foo static initializer. Cool. So the class has been loaded. And then I get an exception because the deserialization process has told me, as you'd expect, that this class of random foo will not fit in a field that's of type string. That's exactly what we would expect to happen. But look, there's a word there, instance. foo has been created, an instance of foo has been created, but we didn't get that message. And we didn't get that message because, and I can't stress this enough, in Java serialization, constructors, deserialization process, constructors are not called. They are bypassed. And if you think about it, that makes sense, because what you're expecting to have is a fully formed Java object being turned from a binary form back into an object form. There's no particular reason to run constructors. So therefore, any of the validation logic that you may put into a constructor to make sure that everything's okay gets bypassed. So the bad guys can change the data, and none of your carefully constructed validation is ever going to get referenced. Right? And the fact that it failed, the fact that I got a class cast exception, yeah, it's disappointing from a bad guy's point of view, but I still got code to run. I still managed to trigger some static initialization. And maybe I could trigger something else depending on the objects that I'm trying to drive. So let me just reiterate this. The constructors do not get called. Data just gets put into the slots based on whatever's in the Java serialization form. Okay, so what happens is another instance of foo. It's got an array called data. The data is filled in by the constructor. So I get some array with values 1, 2, 3, 4. Not particularly useful, but this is an example. And then there's a method that tells you what the size of the array is. Okay. Now, what happens here? Well, look, if I take that object that I've created, it's now got value 1, 2, 3, 4, and I serialize it, I get this wonderful table. And at the bottom there, I get, hey, there's a field called name, there's a field name called data, and it's got an array, it's got 4 elements, and the values are 1, 2, 3, 4. That's what you'd expect. And okay, so if I deserialize that, right, and then I interrogate the object by calling method size, I'm going to get 4, right? That's what you'd expect. But what happens if I take my self-defining data stream and put a null in? Don't actually give you any data. What happens then? Well, bearing in mind, constructors don't get called, but the instance gets created. So I get an instance of foo, fields are all empty, nothing gets populated. So when I call size, I get an MPE. So think about that as a consequence. That's a really trivial consequence where I can cause an MPE that might have some effect. But I could do the opposite. I could create an array that's so big, maybe you run out of memory. Maybe you have, if you have an object slot, for instance, rather than an integer data array, I could put anything in. So I could put in an object array of arrays of arrays of arrays, or each with sizes of, say, int max or something like that. And I could cause an out of memory exception your application. Crash your application based on manipulating the serializable form of the data. Okay. And it's not just direct implementations of serializable that are at risk. If you extend an object, if your object extends another object, even if it doesn't implement serializable, it can be dragged in. And the consequence of that is that the constructor of that parent will get called, possibly not the way it was expected. So as I said, constructors don't get called as part of the deserialization process, but this is the exception. If the parent doesn't implement serializable, then the no-args constructor is called. So again, it's a bit strange, but it effectively means that you dragged that parent into the process. And the other way of being dragged in is if you implement an interface. So if you provide an interface, let's say I have an interface called ifoo, and then somebody implements a class, that somebody creates a class, in this case foo impl, that implements my interface, that's the a common pattern. The way it stands at the moment is the foo import serializable? Is the one in the middle serializable? No, because it's not implementing iSerializable. But if for some reason that first interface extends the serialized interface, then obviously through object inheritance, suddenly your object is now your class foo import is now a full part of Java serialization. You got opted in and you didn't even know about it because somebody else changed their definitions. That's not the greatest place to be. This has been a really whirlwind tour. I want you to understand just how with Java serialization and the manipulation of these self-defining data streams, that with the right circumstances, the bad guys can call denial of service attacks by creating objects of enormous size, or can drive your code in ways you weren't expecting because the data is not what you're expected. And obviously what they're really trying to do is figure out how to construct a sequence of object instantiation, what's called a gadget chain, so that they can run code. And bear in mind that under the right circumstances, they can drive any code that's on your class path through this sort of mechanism. And that's what they'll do. And if you think that creating complex gadget chains to allow people to do that is complicated, it is complicated, but believe me, there's lots of tools out there that will help you make it happen. What can you do to be safer? Well, there are a few things, right? You can opt in to the deserialization process, so you can become part of the process, not just saying you want to be deserialized or serialized. And you can construct defenses by using this sort of method. Read object. See the one in the middle? Read object input stream. Okay, it's a private method. It throws IO class and class not found exception. That will get called, if discovered, it will get called as part of the deserialization process. And that's cool because that means you could put some validation into that point to make sure that the data coming in is correct. The challenge is that it says private void read object. That method signature, it's a private one. So you have to put it on every single object in an object hierarchy. And if you get it wrong, so you spell it wrong, you get the signature wrong, it will not get called and you will not know. So it's quite a complicated way of solving the problem. Now, admittedly, you could do this and rather than deal with it by perhaps validating the data, you could throw an exception and that would stop you being deserialized. But as I said, you have to get that signature exactly right or it won't get called. And if it doesn't get called, the deserialization won't tell you because as far as it's concerned, it didn't find a match. There are other things you could do. Oh, I think I've just said this one. Yes, you can opt out. But as it says, you have to add it to every single class. So if you don't want to be part of serialization, you don't want to be pulled in, then every single class in your application has to have a method like this that is exactly the right signature. That's a lot of work. There are technologies built into the JDK now for you to reduce some of the exposure. So I said about being able to overload you by creating large arrays. Well, there are some controls on that to minimize the maximum size of an array. It's not the greatest tech. It's very much based on regular expressions and bits and pieces. So you have to know what's coming down the pipe. You can whitelist, so you can make sure that only the classes that you would like to be exposed to be loaded by deserialization will happen. Again, you have to take the heavy lift, the work to make sure that you get it correct. And if at any point you get it wrong, then you get an exception. It's quite clunky, but having said that, it is better than nothing. Yes, and Java 17, slightly better. You can now start using better patterns, etc. Right. What else could you do? Well, the attackers only call the code that they can access. So what's on your system class path? So if you're using Java modularity, that would help because modules don't have the same reach and the access to the full class path. So that would help reduce exposure. The other thing is perhaps not use Java serialization in the same way. Maybe don't try and take the large complicated data structures that you've got. Maybe construct some smaller ones that you're going to serialize instead, that perhaps a little bit safer. You still have to do the work to convert from the Java object graph to something else, but that's less hackable, it's a bit more understandable. And of course, with Java records coming along, that thing gets a little bit easier again. Or maybe you go the whole way and you don't use native serialization at all, and you drop out completely and convert your Java graphs into JSON, XML, whatever. Now, in some ways that will help because there's no way for you, if it's under your control, you're not putting class names in, you're in complete control. But of course, again, you've got to do it for everything, and that's quite hard and complicated and fragile because you have to keep these things up to date. You now have two forms of your application. You have the application form in its Java format and the application form in some other format, and you have to make sure that they keep in sync. Here's the challenge for you. Java serialization, the self-defining nature, is very, very powerful, really easy to use, and in the right places, perfectly reasonable to use to solve a lot of problems. The challenge is that the self-defining nature is the thing that bites us because of this ability by the bad guys to play with those bytes and change what you're deserializing. And our defenses, the way that we can write Java code to track and prevent that, aren't particularly great. Now, Java serialization has been a problem for a long time, and we're incrementally getting better. There are more ideas on the horizon, more ways of thinking about it. But right now, it's still an Achilles heel, and looking at different ways of doing Java serialization where you get the same benefits with the same ease of use, it's really a good idea. Because at the end of the day, the bad guys are going to do whatever they can to run your code in ways you weren't expecting, to get at your data, crash your system, etc. And I'll leave you there.
Welcome to the second part of our session. In this part, you will learn how you can eliminate the biggest security leak of Java to make your software applications highly secure if you don't want to be hacked. This is where it gets exciting for you guys now. My name is Markus Kett. I am CEO and co-founder of the MicroStream open source project. We as a team are contributor to the project Helidon as well. MicroStream is open source. You can download it via Maven, and the code is available on GitHub. Since Helidon version 2.4, MicroStream is part of Project Helidon, and Helidon is a great framework for building cloud-native microservices with Java. So it's also open source. Yeah, download it and check it out. All right, Mark Reinhold, the chief architect of the Java platform, said Java serialization was a horrible mistake. And yeah, we have learned why this is really true. And Brian Gertz, the architect of the Java language at Oracle, he said, serialization makes nearly every mistake imaginable. And other encoding, like XML or JSON, is obscure and inefficient. Switching to another encoding does not solve the main problem of serialization. Again, in a nutshell, what are the biggest mistakes of the Java serialization? It's a high secure risk because Java serialization not only transfers data, but also transfers class information, and all serializable classes in the class path are executed automatically through deserialization. And this enables the bad guys to inject malicious code and execute malicious code through deserialization scarily easy. And for the entire Java community, of course, it's a problem because Java serialization is almost everywhere. So it's used by almost any Java application. It's used by almost any framework, by application servers. So it's really almost everywhere. You can try to protect your code by using black or white listing techniques, but these techniques are very simplistic and insufficient. Yeah, and of course you can try to protect your own code, but think of your dependencies. Your dependencies mostly will also use serialization, and protecting also your dependencies is, in practice, is almost impossible. Additionally, Java serialization is also very limited. So it comes with various limitations. For instance, if you want to serialize an object, you have to implement the interface serializable. If you want to serialize an object of a third-party API that has not implemented serializable, you cannot serialize this object. Deserialization is also known as very slow, and it has also problems with the depth of object graph. So this is also, depth of object graph is also very limited. There are around 50 serialization frameworks out there, I guess. And here we have two categories. We have the bytecode-based serialization frameworks, and we have the human-readable serialization frameworks. The problem with the bytecode-based frameworks out there is here also the depth of an object graph is limited, and mostly they make the same conceptual mistakes, or they base on the Java serialization, and so they have the same issues. On the other hand, the human-readable serialization frameworks, they are focused on human-readable formats, and mostly have really weaknesses. For instance, circular references cannot be handled, so it's not really suited for complex object graphs. They produce tons of overhead, parsing is required, and so the performance gets low. This is the reason why we wanted to build a completely new serialization framework from scratch that works fundamentally different to the traditional Java serialization, and also fundamentally different to all alternative serialization frameworks out there. MicroStream works fundamentally different, and so this is the reason why it's highly secure. We separate data and code. We never transfer code or any class informations. We only transfer data. And the second thing is, through deserialization, we never execute code. So the objects are generated by the framework. And so injecting malicious code has no consequences, because executing code through deserialization is impossible. And so we solved the biggest security issue of Java. The security leak is eliminated. And secondly, MicroStream has no limitations similar to the Java serialization. Here we can see a very simple class, and what we see here is nothing specific. So you won't find any annotations, so it's not required to use any specific interfaces like serializable, so you don't have to implement serializable at all. No annotations are required, no superclasses are required. So this is really built for serializing any Java object. So just use POJOs and there you're good to go. If you want to serialize objects of a third-party API, this will be trouble-free. It's also built for very complex object graphs, so circular references are supported, and the depth of your object graph is also not limited. You have no stack-based recursion. How does it work? So using microstream serialization is really simple. You only have to create a serializer that handles byte arrays. So this is only one line of code. And then we have two methods. It's serialize and deserialize, and that's it. So microstream creates initially the metadata of your classes, and only data, so I mentioned it already, only the data is transferred, and only the pure data is buffered off heap, and the objects are created by microstream specific type handler through deserialization. If your classes change, this is really trouble-free with microstream because microstream provides a legacy type mapping. With microstream, you also get a high-performance serialization and to build really high-speed data transfer. Because we use a highly optimized byte format, there is no needless overhead by strings, for instance. You get a redundancy-free data transfer. It's up to 20x faster than traditional Java serialization. You can use microstream wherever Java runs. You can use it in your applications, in your microservices. You can run it in a container, and it works with GraalVM native images. So you can use it for your microservices, and fits perfect with the modern serverless world. We also have an implementation for Android, and the only requirement is Java version 8. Every 6 months, a new Java version is coming out to ensure that microstream works with the latest Java version. We go along with the Java release cycle. This means every 6 months, we provide a new microstream release. Currently, microstream version 7 is the latest version. So you get numbers of benefits with microstream. You get a high-performance serialization and a high-performance data transfer. You get a high secure data transfer. You cannot be hacked anymore by the bad guys who want to inject malicious code through deserialization. It's pure Java, no external dependencies are required. No internal configurations are required. You can use your classes as they are, just use POJOs, and you're good to go. Any object can be serialized. It fits seamlessly with the Java object model, and you get an ultra-fast, redundancy-free data transfer. It's built for simple objects. You can serialize simple objects, but also high complex object graphs. Migration is really simple with microstream, and last but not least, it's open source. Let's have a look on our roadmap. Currently, we're working on microstream for serverless functions. With microstream, you will be able to store the system state of your serverless functions seamlessly into S3, for instance, and you also will be able to share the system state of your serverless functions by using microstream by only one method call. So this is very easy. And also we are working on an AWS S3 storage service that enables you to serialize your objects with only one Java method call into a S3 storage and vice versa. We work on converters for CSV, JSON, and prototype buffers and other serialization frameworks, and also on encryption and blockchain. Beyond data transfer, MicroStream is also a persistence layer because we added additional components to the MicroStream serialization. We built persistence framework for the JVM, and we also provide an implementation for Android. And yeah, we solved the problem that we have if normally if the class is changed. So we provide a legacy type mapping that manage the type mappings automatically behind the scenes. We added a system, a file system garbage collector for the persistence that removes legacy objects from your file storage automatically. We added also a file system abstraction, so your storage can be everywhere. We also added some database connector that enables you to persist your binaries in almost every storage solution. You get a REST interface that enables you access to your persisted data, and on top of that, we provide a storage browser you can use to browse through your persisted data in the file storage. You also get native backup functions and converters, for instance, for CSV or other framework, serialization framework formats. Yeah, MicroStream is open source. You can use it for free. Yeah, take it, eliminate the biggest security leak of Java, and make your applications highly secure. If you want to check it out, you find MicroStream on microstream.one. The code is available on GitHub. Check it out, and we provide also additional videos on our YouTube channel. So now, please feel free to ask any questions. Thank you for joining our session. Thank you and goodbye.